All right, let's look at the homework 7.8, 7.9, problem number 11. All right, so we want to evaluate the integral over the region bounded by y equals 0, y equals square root of x, and x equals 2. And we want to do it in both orders, right? So let's do that. All right, so first we have to know the region we are integrating over. So it's going to be, let's see, so here's the y-axis, and here is the x-axis. All right, the origin. All right, so y equals 0 is just the x-axis. So here is the y equals 0 is the x-axis. And the y equals square root of x, we can draw that. So it's going to look something like that. All right, so this is y equals square root of x. Then we have x equals 2, which is just a vertical line. So 2 is probably around here. All right, then vertical lines through 2. So here is x equals 2. Oops. All right, so this is x equals 2. All right. So that region we are interested in would be this region right here. All right. So let's set up the integral. All right. So first, let's see. So we want to set up the integral. Let's see. I'm gonna do it here. All right. So let's do it with respect to y first, and then with respect to x next. So you have, all right, dy dx. All right. So all right. So second integral is with respect to x. We're gonna fix x. So just pick any x value. All right. Then try to find where this line segment starts and ends. So from here to there, right? So you can see that the y is going to start from 0, then ends at the on the curve y equals square root of x. So this is y equals square root of x, right? So which means that y is going to go from 0 to square root of x. All right. Then after that, we have to start from here. Then you do a bunch of vertical line segments, and you just keep on doing that all the way up to here, so that we can cover the entire region. So it looks like x is going to go from 0 to 2. All right, so x is going to go from 0 to 2. All right, so this is one of the integral. All right, and we can do it the other way. So let's do integration with respect to x first. So here, right, so y over 1 plus x squared dx, right, dy. All right, then let's do that. Let's see. So we're gonna go from, so x. So we have to look at it. Let's say I'm gonna use blue. All right. So fix the x value. So somewhere over here. All right. Then you have using the horizontal line segment to cover the entire thing. So it looks like it's gonna start from here. So x is going to be equal to, so we have to rewrite this guy. Right, so this can be, we can square both sides and write it as x is equal to, y squared, right? So x is going to go from y squared to all the way to x equals 2. So this is x equals 2, right? So it goes to 2. Right, then y is going to go from, right, 0. So here's the starting point. Right, then you keep on having these all the way up here. So that's x equals 2, so it's a square root of 2. So y equals square root of 2 is the last one, right? So y is gonna go from 0 to square root of 2. All right. So so we have that. All right. So let's see which one is easier. Integrating it with respect to x. Looks like this is gonna give you arctangent here. And this one is, maybe the first one might be a little bit easier. So I'm going to try to do this one, right? So those two integrals are going to give you the same value anyway, but so I'm going to just equal to that. But I'm going to work on this, right? So leave the outside from 0 to 2, right? So you can see that 1 over 1 plus x squared is just going to be a constant. So we're going to put it outside here. So 1 plus x squared, right? Then what you have is the integral from 0 to square root of x. And you just have y here. And dy, dx. Right, so this is going to be equal to, right, integral from 0 to 2, 1 over 1 plus x squared. So we'll take care of that later. But this one, antiderivative is y squared over 2. Right, from 0 to square root of x. Right, and we still have to evaluate it with respect to x. Right, so plug it in. All right, so you have 0 to 2, right? So if you plug in here, so square root of x squared, so that's going to be x, actually absolute value of x, but x is going to be positive in this case, so you have x here over 2. So you basically have x here over 1 plus x squared dx. And 1 over 2 is just a constant, so I'll just put it outside. So 1 over 2, right? All right, so we can use the substitution here to evaluate. So I'm going to let u equals 1 plus x squared, right? Then take the derivative of u with respect to x. You will get 2x. Right, take the reciprocal of both sides. So you have dx over du is equal to 1 over 2x. Then we can just multiply both sides by du. Right, so dx is equal to du over 2x. Right, so put that back in. So you're going to have, right, so 1/2 is just 1/2, and the integral, right? So I'm going to leave x as it is, right? But the denominator is u, right? dx is same thing as du over 2x. All right, so you can cancel x on top and the x on the bottom. All right, we can pull out the 1 over 2 outside. So you will get, so let's say I'm gonna actually go over here. All right, so it's gonna be, let's see, 1/2 and the 1/2, so it's 1/4 integral. Oh, I forgot to do the limits. So you have, if x goes from 0 to 2, then u is gonna go from 1 plug in 2 squared 4 plus 1 is 5. So it's going to go from 1 to 5, right? So it's a 1 to 5, right? Then this is just going to be 1 over u du, right? Then you have 1/4. Antiderivative 1 over u is a natural log of absolute value of u. And going from 1 to 5, then you have 1 over 4 natural log of 5 minus natural log of 1. Right? But we know that the natural log of 1 is 0. So therefore, we know that it's a natural log of 5 over 4. All right? So that's the value of the integral there. All right? So let's type it in. All right, so value was, so you have natural log, so ln of 5 over 4. All right, let's check the answer. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.